Hello.
Hi.
You guys want to give this a shot? It's two very easy multiple choice questions.
Okay.
Yeah, so let's see if you guys can get them. Very easy.
If we do bad and we look stupid, don't post this.
Well, this one's already live, but it's facing me, so you'll be okay. But trust me, it's just very easy. So here I have 3 box trucks, and there's a bowling ball hanging with a string. So a bowling ball. So one truck is accelerating forward, one is at rest, and one is accelerating in reverse.
Right.
So out of these 3, which one is at rest?
This one.
Yes, you guys got it. Why is that one at rest, would you say?
The bowling ball is not moving.
Exactly. Okay, pretty easy, right? So which one's accelerating forward?
This one.
Yes. How do you know that one's accelerating forward?
Because the bowling ball is moving backward with, like, inertia.
Inertia, exactly, inertia. But the bowling ball is actually not moving backwards because...
Right, it's staying in the spot
yes.
where the truck is moving
Yeah, so it's being
forward,
left behind,
Yeah.
in other words. But yeah, but due to inertia, exactly. In reverse. You got it. See, pretty easy, right? So this next one is pretty similar, but it's a helium balloon now instead. So with the string. So out of these 3, which one is at rest?
Wouldn't it be B?
Yeah, it actually is. And it's for the same reason as the first one, because it's not moving in any direction, right? So which one is accelerating forward now?
I want to say A.
Okay, which one's, what will be your final answer, I guess, will it be A?
I'm trying to think about the time I had a balloon in the car and which way it moved.
Pretty much, that's what it comes down to.
Okay, I feel like it might be C.
Yeah,
Because helium is less dense than air.
that's true.
Okay, that's actually really good. You're probably one of the first ones since I've been doing this to actually get it right and actually give the explanation to why. Yeah, so it is true because helium is less dense than air. When you accelerate the container in this direction, the air is also moving through space in that same direction, and because helium is less dense than the air is able to push it in that same direction. So that's what we will call buoyancy. It's a chain reaction of a force, or in this case, the acceleration of the truck. And I can demonstrate it here too. I have a ball that's less dense than the water. If I accelerate in this direction, what direction do you think the ball is going to go? Being less dense than the medium.
That direction.
Exactly. See, it's pushed in the same direction as the force, because again, that's what buoyancy is. So since we understand these simple, I guess, demonstrations, right? I actually did this experiment myself, with an apple hanging with a string and a helium balloon also with a string, right? Since we understand, yeah, exactly, it's pretty crazy, huh? So since we understand helium always follows the direction of the force, what direction would you say I accelerated this then? To the right or to the left?
To the right.
Yes, exactly, because obviously, if I told you it was accelerating to the left, obviously I'll be lying.
Right.
Because that defies physics.
Yeah.
Exactly. Helium will always get pushed in the same direction the air is moving. Exactly. So here, I even did it with a similar one to this one, with a steel ball and a ping pong ball. Again, what direction did I accelerate this container?
In that direction.
Yes, exactly, because that's the direction of buoyancy. The steel ball didn't swing back. It was just being left behind. Again, because the water's not dense enough to push it like the ping pong ball, the steel ball just gets left behind. So that's what we experience here. So one last one, real quick. Again, I had a water bottle like this with a ping pong ball and a steel ball. I had it at rest, but I only accelerated one of these 2 down. Which one did I physically accelerate down? The one on the left or the one on the right?
The one on the right.
Exactly, because we see the reaction to that acceleration. Again, the ping pong ball gets pushed down along with all the air, and the steel ball gets left behind.
Right.
So that's how we get that multi-directional motion, right? So the one on the left, it was actually free fall. So let me ask you guys this. If I was holding this bottle right now and I just simply released it, it didn't accelerate, it just released it down. Do you guys believe gravity accelerated down to the earth from being at rest? Like if I release it into free fall, do you believe it got pulled down towards the earth?
Yeah.
Yeah, right? So again, they claim that gravity accelerates matter at 9.8 meters per second, right?
Yeah.
But the one on the left is actually free fall, and we see no reaction of matter whatsoever. So matter doesn't react to that acceleration in free fall. And I don't know if you guys knew, gravity is just theory. Right. So what that means, it has never been physically proven or measured. Because again, we can clearly prove to ourselves that there is no reaction of matter in free fall because there is no force in free fall. So objects don't accelerate down when you release them into free fall. You guys want to know what happens in reality? So what happens is, since we understand buoyancy follows the direction of the force, right? If I have a helium balloon here on Earth and I release it, what direction does the helium go? Why do you think it goes up?
Because force goes up? Or
Yeah, the force is up, but what's pushing the helium up, I guess, will be my question.
Atmospheric pressure.
Yes, the air pressure, the atmosphere, the air, because the air is more dense.
Right.
But we understand that in order for the air to be able to push the helium in any direction, the air also has to be moving in that same direction. So if the air is moving up to be able to push the helium up, what's pushing up the air? Or what's moving up the air, I guess?
Normal force.
The normal force, yes, exactly. The normal force is the upwards push of the Earth.
Right.
So that can be physically measured and tested and proven that it's there. Because buoyancy is a force, but again, it's a chain reaction of a force, because a helium balloon doesn't push itself. It requires the air. But the air can't push itself either. So what's pushing up the air? It's the Earth literally pushing up right now. So you're not being pulled down towards the Earth. That pulling force doesn't exist. It's literally the Earth pushing up against you. And that's why we're stuck on Earth. Because it's the Earth constantly pushing up against us. So when I release this object into free fall, it's not the object that moves down towards the Earth. It's the Earth that comes up to the object. So because right now everyone's connected, we can feel the pressure under our feet. We're literally being pushed up right now. You could kind of think of it like a giant elevator. The Earth is. So when I release this in space, it's being left behind. Because the air, again, is not dense enough to push it up, just like a helium balloon.
Right.
So it's the Earth that just comes into contact with it again. So let me ask you guys this. You guys believe the Earth is a ball, right?
Yes.
If we could prove that the Earth is literally pushing up right now and it's not pulling us down, right? How can the Earth be moving up in every direction on a ball because obviously up is relative on a ball, right? If you're standing here, up is this way. If you're standing here, up is this way, in every direction away from the center.
Mm-hmm.
But if we could prove that the ground is literally pushing up, how will that work from a ball Earth? How can the Earth be pushing up in every direction at the same time?
Because it's coming from the center of the Earth.
But if we're up here and it's pushing up this way, how can it push down at the same time and then this way?
Because it pushes in all directions.
So it's pushing up in all directions.
Yeah.
So how would that work though? Because
it's coming from the center, not from the surface.
but the ground, the surface is literally pushing up. It's literally moving up through
Because
space.
the surface is the closest that we can touch to the core of the
Yeah.
Earth.
Yeah.
So
this is, correct me if I'm wrong, but if the Earth was literally pushing up in every direction on a ball, that would mean the Earth will have to be expanding. It will have to be growing to be able to push up in every direction away from the center. So it will have to be growing into infinity to be able to push up. Would you agree or disagree?
I'm not sure that I would agree with that.
Well, okay, if
But
the ground,
I guess
if the
we
ground
don't
was,
really know if it is.
but that's the thing. Buoyancy shows us that. But let's say if the ground was literally moving up, right? How else would it work?
It's not literally moving up. It's
But that's
pushing.
How can something push something without moving?
I can push my hand on this,
But
and
that's
neither of us are moving.
Yeah, because you're exerting the resistance of this table is greater than the force you're applying. That's why.
Right.
Yeah, but you're still moving towards the table to be able to apply pressure. There's a motion right now of you pressing down on the table.
Yes.
You can't have pressure without motion. That's what a force is.
Right.
Yeah, force is F equals ma. It's mass and undergoing acceleration or
Right.
motion. So that's what a force is. So you can't have a force without motion. So the Earth does exert a force, but it's not a pulling force. It's a pushing force. So the fact is,
But you said that there's also atmospheric pressure. Why isn't that pushing down? It is. It keeps us on the Earth.
no. Well,
They balance each other out for us to not be floating.
yeah. So again, the atmospheric pressure. Again, if something is falling through the air, right, or appearing to fall, the air is simply just not dense because the air is moving up through space. That's how it has pressure. That's the reason why we have air pressure here. And it decreases the higher you elevate, like when you go on top of a mountain. It's because there's less mass above pushing, resisting, I guess you could say. Because matter resists because of inertia, right? So again, air pressure is only there because there is a force over the Earth. But again, that force is not a pull, it's a push. Again, if you globe Earth believers will say that, oh, it's the pulling force of the Earth that's pulling the air down, that's creating that pressure. But then a helium balloon goes in the opposite direction, which defies physics.
Can I clarify something?
Yes.
This is, you believe the Earth is flat?
No, the Earth is not flat. So the flat Earth is a psyop. So let me explain this before I guess you get to your next point. So over 95% of flat earthers claim the Earth is motionless. So that's the mainstream flat Earth. So the
Okay.
whole globe Earth versus flat Earth is a false dichotomy because motionless flat earthers actually
Okay, 'cause
believe.
you believe something in between the two.
No. So here's the thing. Motionless flat earthers believe also that there is some kind of pulling force. But they deny gravity. They claim it's something else. They don't even have an explanation, yet alone a practical demonstration. The fact is, the Earth is a level plane that's in upwards motion because level is an orientation, which requires a force. In order for something to be level, it needs to be undergoing a force. You know, and that force is the vertical, but it's not down, it's up. So that's the big psyop, pretty much.
So you believe what?
So if the Earth is a level plane, that's in upwards motion.
Okay.
Yeah.
So
the
you believe that it's flat.
Well, I don't have-
theoretically, but not
no,
like
because
the
level and
Earth.
flat are two completely different things. Because something that's
Okay,
flat,
level to what?
level to the vertical force of the Earth, relative to the vertical force. That's what gives us orientation, is the force of the Earth.
Okay.
Yeah, motionless flat earthers, which is the mainstream flat Earth, which
So is there an underside?
nobody's been outside of the Earth. So the Earth is a contained
Nobody
system.
has been outside.
Nope.
Of the Earth.
So the Earth is a contained system as well. So again, we have air pressure here on Earth, 14.7 psi. In order to maintain air pressure without, losing air pressure, the air has to be physically contained by some kind of physical barrier. So the Earth is being contained by some kind of physical barrier, in my opinion.
So maybe like snow.
You could say that, but if I'm being honest, I don't know what that container looks like.
A snow globe?
No, you could say that, but in reality, nobody knows what the container looks like.
Right.
I don't know what it looks like. I don't make any claims that I can't prove, but physics shows that the Earth, again, in order to have air pressure, you need a physical barrier. And in order to have buoyancy, you need a force. You need something pushing on something else that's pushing something else.
Right.
So again, in my opinion, the number one proof that debunks the globe Earth is the fact that there is no pulling force of gravity, because the whole heliocentric model relies on that belief. Because in order to believe the Earth is a ball, you first have to believe in the pulling force of gravity, because then how do they explain people sticking to it and
Do
all
you
that?
believe in the heliocentric?
No. The whole heliocentric model, in my opinion, is a lie, obviously.
Well,
But
we do have to go.
before you guys go, I guess, 1 minute, what's the number one reason that makes you believe the Earth is a ball? I just...
I don't know, maybe our education, maybe believing that the moon landing was real and
Okay.
not a conspiracy.
Right. Would you say it's based on faith, then? Why you believe the Earth is a ball?
Faith, I don't know, maybe trust in science.
I would trust faith, I would say it's the same
Right.
tomato.
Yeah.
Because you shouldn't trust science. Science should be measurable, testable, and repeatable. We should be able to prove it to ourselves.
Which we have measured gravity before in
Well,
labs.
Well, not even Einstein did. That's why he came up with the theory of relativity. And it's called a theory
But they
because...
don't push theories widespread unless they're
Unless they're
pretty
trying to...
well proven.
Well, that's the thing. If it was proven, then it wouldn't be a theory. And they
Not
push it as a
necessarily.
theory. Yeah, if something can... It's not a theory that
If
cell
it can
phones
be
exist.
proven, then it can still be a theory.
You
which-
could build theories off of something that's true. I agree with that. But the claim that gravity is a pulling force, that's not true. And it's based off of nothing. It's not based on any practical physics. So that's why it remains a theory. But yeah. All right.
I hope you have a
Appreciate.
good day.
Yeah, thank you. You too.
You got some trivia questions?
Oh yeah, 2 multiple choice. Very easy questions. So we'll start with the first one here.
Oh, good.
So I have 3 different box trucks, and there's a bowling ball hanging with a string in all 3 box trucks. So one of these box trucks is accelerating forward, one is at rest, and one is accelerating in reverse. So out of these 3, which one is at rest?
B.
Yes. Why would you say B?
Because it's not moving in the right or left direction.
Exactly. It's not reacting to anything, so it's at rest. So which one's accelerating forward?
A.
Yes. Why would you say A?
Because it's moving opposite of the car's direction.
Okay. Yeah.
Because it's heavier.
Yes, exactly. Due to inertia.
Yeah.
That's a simple. But could we say that the bowling ball is being left behind, and it's the
Yeah,
whole
for
truck?
sure.
Exactly, right? So it's
Yeah.
being left behind. Exactly. Perfect. You got it. So the second one, very similar, but instead of a bowling ball, is a helium balloon. So again, same thing. Out of these 3 box trucks, which one is at rest?
Yeah, I'm gonna go with B again.
Yes, and it's for the same reason.
Yeah.
The first one, exactly. So which one's accelerating forward?
Damn, bro. I don't know if it's a trick question or not, but I want to go with A again.
Okay.
But,
Nah, yeah, this one's actually C.
yeah.
Yeah, and let me explain why. The reason why it's C is because when the truck is accelerating in that direction forward, for example, the air also in the box truck is also being moved in that direction because it's being contained.
And helium is lighter than air.
Yes, so
yeah.
air is able to push
That
it in
makes
that same
sense.
direction.
That makes sense.
So again, that's what we will call buoyancy.
Yeah.
So buoyancy always follows the direction of the force.
Yeah, this
Or-
is bad.
no, yeah. So again, I have a buoyant object here inside the water that's more dense than the ball. If I accelerate the container in this direction, what direction will the ball swing?
So you got that.
It's obviously less dense than the water. So
Yeah.
what direction will the ball go if I accelerate this
I'm
direction?
just gonna go in the same direction.
Yes.
As C, like forward, right?
There you go.
Alright,
You got it.
so-
Again, perfect. So here, let me show you this. Since we understand buoyancy always follows the direction of the force,
Yeah.
here I did it with a helium balloon in a cargo van and an apple, tied to a string.
Oh, that's pretty cool.
Yeah. So what direction would you say I accelerated this van, to the right or to the left?
To the right.
Exactly.
Yeah.
So the apple is not swinging in the opposite direction; it's just being left behind.
I feel you.
Exactly, because the air is again pushing the helium balloon, but the air's not dense enough to push the apple.
No, that's real.
No, yeah. So here, let me show you this real quick. So matter will always react to acceleration 100% of the time. So let me just show you this one. So I was holding a water bottle like this with a ping pong ball and a steel ball, and I only accelerated one of the bottles down. Which one would you say I physically accelerated down? The one on the left or the one on the right?
No, I'm on the right.
Yes, exactly, because that one shows a reaction. Matter reacts to that acceleration, to that force.
That's pretty
Yeah.
chill.
Okay, let me ask you this. If I was to just hold it and release it into free fall, in other words, I didn't accelerate it, but I just simply released it into free fall, do you believe it got pulled down towards the earth? It accelerated down towards the earth?
Yeah.
Yeah? So here's the thing. The one on the
Don't
left,
tell me I'm wrong.
here's the thing. The one on the left is actually free fall. I just released it, but we see that matter didn't react to that
That's 'cause it's
acceleration.
full, no?
No, it should react because the water should be able to push the ping pong ball in that same direction because the water's also moving in that same direction through space. But I don't know if you knew gravity is just a theory. What that means is that they never physically proven gravity because a physical downwards acceleration has never been measured because matter doesn't react to acceleration in free fall.
Are you about to say the Earth is flat?
No.
Okay.
But I am getting to how the globe cannot be a ball because flat Earth is a psyop as well. But here, let me tell you this. When I have a helium, if you understand buoyancy follows the direction of the force every time.
Alright.
If I have a helium balloon here on Earth and I release it, what direction does it go? Why does it go up, do you think?
It's lighter than air.
Yes, so the air, could we say, is pushing it up?
Yeah.
So again, the air, in order for the air to be able to push helium up, it has to also be moving up in that same direction.
Okay.
So what's pushing up the air to be able to push up the helium? What do you think?
The natural ebbs and flows of the air. It's constantly moving. Like, I feel wind right now.
Yeah. I would say the wind we feel is because the different pockets of air pressure here on Earth, so the air moves to fill in those gaps, so we feel the air rushing. But the reason, why do you think helium goes up though? Why doesn't it go to the side or to the left or down? Why does it go up?
Helium itself?
Helium itself, for example, if you have a helium balloon, why does it go up? It has orientation, that's why it goes up. Why?
For sure. I mean, I'm not
It
crazy
is-
versed on the chemistry, but I'm sure that helium itself has a lower atomic weight than oxygen or something
Yeah,
like that.
so again, we go back to the air pushing it up. So the fact is, air cannot push itself either. So the Earth is pushing up the air, which is pushing up the helium.
I mean, naturally,
That's what's happening.
if something if you push wind that way and it disperses, isn't it it's dispersal gonna go in all directions, including up? So if I have a fan, eventually would I blow it's only gonna blow for as strong as it is,
Yes.
and then it eventually
It just
starts
goes up.
slightly,
Yeah.
and it's a little down, but mostly up, because you know.
Yeah.
it's
So
natural.
here's the thing, because a lot of people would say, "Oh, gravity pulls the air down, and then air is able to push helium up." That defies physics, because the air has to be moving in the same direction that the helium is moving. Cool. So here's the thing: when I release this object into free fall, it doesn't accelerate down because what's happening is when I release it, it's the Earth that comes up to meet it.
Yeah.
So this it looks like it goes down because we're also moving up with the Earth as well.
Oh, so you think?
So everything is moving up right now. So when something's not connected to the Earth, then it simply It's simply the Earth that's moving up to catch up to it. So gravity is not a pulling force of the Earth, is a pushing force. Exactly. And that's why gravity as a pulling force is just a theory, because it doesn't exist.
Okay, for sure.
So let me just ask you this before you go.
No problem.
You believe the Earth is a ball, right?
Yes.
On a ball, up is relative. In other words, if you're standing here, up is this way. If you're standing down here, up is this way. In every direction away from the center.
Yeah.
So up is relative on a ball. If we could prove that the Earth is literally moving up, pushing up, in other words, how would that work from a globe Earth? How can it push up in every direction at the same time if it was a ball?
We can't.
Exactly.
That's why we don't believe
It can.
That's why we don't believe Earth is beating us up.
Yeah, because that would mean the Earth will have to be expanding, and it would just explode. If it was pushing up in every direction, it would have to be growing. So the fact is, in order for people to believe in the ball Earth theory, they have to believe in the pulling force of gravity, which doesn't exist.
Yeah.
So the fact that the Earth is the force of the Earth is a pushing force debunks the entire globe Earth and the whole heliocentric
Oh,
model.
never mind. He doesn't waste time.
Yeah.
I know.
So
I know.
phys-
It's just
so-
that right now I'm working on a physics lab, and like if I get caught on camera not being able to prove that,
So let me ask you this: what's the number one proof that makes you believe the Earth is a ball?
it's like
No, why do you believe the ball Earth? No, why do you believe it?
I just want
Because
to
you
know,
were told, huh?
I just want to know.
Yeah,
you're
that's why
getting-
you believe it.
You're getting to the Earth is.
No, you didn't. Physics shows me that it's not.
You're
Physics shows me that it's
you're
not.
getting to the Earth is.
The Earth is not flat because over 95% of flat earthers believe the Earth is motionless. So the whole globe Earth versus flat
So
Earth,
what shape do you think the Earth is?
the Earth is a level plane.
Okay.
Levels in orientation that's relative to the vertical force.
That's what you have to say.
Yes.
Alright.
This doesn't work in free fall. So if
Okay.
you're in free fall and you try to level this, it won't work.
Yeah,
This,
I feel you.
yeah. So yeah, the Earth is not a globe, and physics shows that.
Godspeed, bro.
Yeah,
You got
I
it.
appreciate it, man.
Of course.
Yeah, your friend there got a little triggered. He wasn't even part of the
Are
conversation.
you gonna post this somewhere?
Well, I'm live, but it's recording me.
Okay.
But here, take my channel. I go to all the universities here in Southern California, and I talk to all the students who want to check it out. Here you go, man.
I'll take a picture of it.
Oh yeah.
What is the trivia thing I could win money on? Do you post like the clips or something?
Some of them, not all of
Okay,
them.
okay.
But yeah.
This one isn't posted really. I mean, I was just.
No
If
worries,
you
man.
Post it, just make sure you post the part where I thought I was gonna win money.
No worries, man.
Alright.
All right, take care. You guys want a shot? Okay, it worked. They were just gonna walk away. All right, all three. You guys could do it together too, to make it easier.
Is it
So,
experiment?
yeah, it's two very easy multiple choice questions.
Multiple choice. Oh,
Multiple
okay.
choice. Yeah, very easy.
Oh.
So I have box trucks here, 3 box trucks, and there's a bowling ball hanging with a string. So out of these 3 box trucks, one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
Rest.
Yes, B. Why would you say B?
Because the ball is stayed here.
Yes, it's not swinging or it's not moving.
Yeah.
Exactly, yeah, you got it. So which one's accelerating forward? Yes. Why do you say A?
Because this ball is.
Inertia? Because of inertia?
Yeah.
Yeah, because of inertia. So the whole container is moving forward and the bowling ball is being left behind, pretty much, due to inertia.
Yeah.
So yeah, so it appears to swing back, so yeah, you got it. Pretty easy. So the second one is pretty similar, but instead of a bowling ball, is a helium balloon. So out of these 3, which one is at rest? B, yes, you got it. For the same reason that the first one.
Accelerate.
Accelerating forward. Which one's accelerating forward? You say A? Which one would you say? A too?
Yes.
Which one would you say is accelerating forward? A?
Yeah.
In this, it's actually C.
Oh, why?
Yes, and I'm gonna explain why. Because when you accelerate the container, or in this case the box truck, in this direction, all of the air inside of the box truck is also being moved in that direction. So because air is more dense than helium, the air is able
Oh,
to
it's a
push.
helium.
Yes,
Oh,
it's
you
helium.
did?
Oh, yeah, I did say it was a helium. You probably didn't hear me.
Oh.
Yeah. So helium always follows the direction of the force.
Oh,
Because it's less dense than the air that surrounds it. Then I can show that here. Look, this ping pong ball is less dense than the water that surrounds it. If I accelerate the container this way, it goes in the same direction.
Oh.
Yeah. So buoyancy always follows the direction of the force.
Yeah.
So here, let me show you this. I did it in a cargo van with a helium balloon and an apple. An apple is obviously more dense than air, and a helium balloon is less dense than air. So understanding,
Here is an apple.
Yeah, the apple's red, the helium balloon.
Oh.
So what direction would you say I accelerated this cargo van? To the right or to the
Yeah.
left? To the right? You got it. Yeah, because again, the helium balloon is showing you that the force is acting in that direction because the air is pushing it in that direction. So let me ask you this. So I had a water bottle like this with a ping pong ball and a steel ball, and I was holding it like this, and I only accelerated one down from these two. Which one did I accelerate down? The one on the left or the one on the right?
Ping pong?
Yeah, there's a red ping pong ball and a steel ball. The one on the right, yes, that's the one I accelerated now. Because we see that the matter reacts to that acceleration. That's another thing, matter will always react to acceleration. Especially when it's at rest, and then you accelerate, matter will always react. And then relative to the medium that surrounds it, that's the direction that they're gonna go, right? Now let me ask you this. If I was to just hold this at rest right now like this, and I released it into free fall, do you believe it accelerated down toward the earth? Like the bottle, if I release it?
You mean just the bottle, not the water?
Well, everything. You believe this whole thing accelerates down to the earth when I release it into free fall?
No.
Yeah, right? You believe gravity pulls it down, right?
Yeah.
So here's the thing. The one on the left was actually free fall. I just released it, but we see that matter didn't react to that acceleration. So there was no reaction to acceleration in free fall because there is no physical downwards acceleration. I don't know if you guys knew, gravity is just a theory.
Yeah.
So that means that gravity as a pulling force has never been physically measured. So then the reason why is because matter doesn't react to acceleration in free fall because there is no physical downwards acceleration. So what's happening is, if we understand buoyancy always follows the direction of the force, if I have a helium balloon here on Earth and I release it, what direction does it go? Up. Exactly. Why do you think it goes up?
Because the weight is less than
In the air?
air.
Yes. So the air is able to push it up, helium. We understand matter cannot move itself, just like the helium balloon cannot move itself. It relies on the air pushing it up. Air is inanimate matter as well that cannot move by itself. So what's pushing up the air to be able to push up the helium? There actually is, and you're standing on it right now. The Earth. So the Earth. So they call it the normal force.
It's also gravity.
Well, that's the thing. Gravity, they're claiming it's a downwards force, but that has never been measured or proven. So that downwards force actually doesn't exist. The normal force, however, it's the upwards push of the Earth. So the Earth is literally pushing up the air right now, and pushing up against you right now as well. And that same force of the push of the Earth is what pushes up the helium balloon through the air. So right now the air is moving up through space, but because we're all moving with the Earth together, it doesn't seem that way. But when I release an object into free fall, the reason why it doesn't accelerate down is because the Earth and everything else within it is moving up to meet it. So the helium balloon is less dense than the air, so it gets pushed up. This is more dense than the air, so the air is not able to push it up. So the Earth just catches up to it.
The Earth is extract both air and the helium.
Yes, the Earth is pushing up the air, which is pushing up the helium. So that's what we will call buoyancy. So let me ask you guys this. You guys believe the Earth is a ball, right? So up is relative on a ball. In other words, if you're standing here, up is in this direction, but if you're standing down here, up is in the opposite direction. And it's in every direction away from the center, up. If we could prove that the Earth is literally pushing up right now and it's not pulling you down, in other words, it's moving up, how can the Earth be moving up in every direction simultaneously if it was a ball?
Because they're core.
Yeah, but how would the surface of the Earth be able to push up or move up in every direction at the same time if it was a ball?
How to push the air up?
Yeah, exactly. Because physics shows us that the air pressure is acting in this direction, up. And that's why helium goes up. Because that's the direction that air pressure is acting. But the air pressure doesn't create itself. So I'm saying is that the Earth, the ground, is literally pushing up right now. And that's creating the air pressure. And physics shows us that. So how would that work from a globe if the ground was literally moving up through space?
anything else in the space?
A lot of people would say, like, they would still say kind of like the spin of the Earth. They'll say the spin of the Earth, but that has nothing to do with the ground moving up. So here's the thing. In order for the ground to be able to move up, if it was a ball, that would mean the Earth will have to be expanding. So it will have to be growing in every direction to be able to push up in every direction. But that would mean the Earth would just explode. It wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force, which is the main thing of the globe Earth. But the fact is, the force of the Earth is a push, not a pull. But if we actually understand that if it's literally the ground pushing up, then the Earth, again, as a globe, wouldn't exist, and not even on paper. So the number one proof to debunk the globe Earth is the fact that the force of the Earth is a push, not a pull. So the Earth is actually a level plane like this, and we're all standing on it. So orientation here on Earth is not relative, it's singular. So everybody here on Earth experiences the same up and the same down. Because again, the Earth is just an extended plane that's pushing up. It's not a ball that's pulling you down. So that's the fact. So gravity, again, the force you're feeling right now, it's the push of the Earth. You're not being pulled down to the Earth, you know, and physics shows us that. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the Earth is a ball? Or why do you believe the Earth is a ball?
It's so we saw a lot of pictures.
Pictures?
So yeah, like you set up a camera in the space. Yeah, it looks like
Okay.
it's a ball.
So I actually I do have a couple of photographs here, or pictures, because they're not photographs, but from NASA.
Yeah.
And I bring them here just to show people, because I know that that's one of the reasons why people believe it. Yeah. So this is an image from 2012, and then here's an image from 2002, and these are official NASA images. You can look them up.
Yeah.
They admit that these are CGI, so they admit that they don't have a real photograph of the Earth as a whole from outer space. So everything that we're being shown from space agencies is all CGI, admittedly so. So the fact is that a genuine photograph of the Earth from outer space doesn't exist. Yeah, so it's a bit weird, right? Trust me, when I first came across this information, kind of like made me question a lot too. Why do you think that is? Why don't we have a real photograph of the Earth from space?
Why? It's because
I mean, you can see here that they're completely different shades, different sizes of North America, and
Yeah.
you know, it's just they're cartoons, in other words. Everything that we're shown from outer space and about outer space is all cartoons, CGI, in other words.
okay.
Yeah.
I don't know that.
Yeah, a lot of people don't know that. Yeah. Let me ask you this: if I showed you a picture or a video of me flying, would you believe I could fly? If I just showed you a video,
I don't believe.
why wouldn't you believe me?
I think that's AI.
Yeah, it will 100% have to be AI. That's the logical conclusion. Why? Because human beings flying defies physics.
Yeah.
Exactly. So if you show me anything that defies physics on a video, I automatically know it's fake.
Yeah.
So like if you show me walking through walls, you know, like a video of, and we know it's fake, that defies physics. So the ball Earth claim defies physics. Because again, the force of the Earth is a push. That would mean the Earth will have to be growing in order for it to be a globe. Here's another, this is the number one proof, again, the fact that gravity is a push. The number two proof is, do you guys know the radius of the Earth that they tell us? Like the radius? The radius of the Earth. That's the distance from the center to the outer circumference.
Yeah.
Do you know the radius?
Oh, we don't know the exact.
Yeah, so they do tell us the radius, look.
Yeah.
So the radius of the Earth is 3,959 miles,
Okay.
which is the distance from the center to the outer circumference,
Oh,
right?
yeah.
So the diameter will just be the radius times 2. That will be completely across.
Yeah.
But when they give us the radius, using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared,
Yeah.
we can physically measure for how much curvature there should be if the Earth was a ball. So based on the radius that they're giving us, there should be 8 inches per mile squared that should be measurable here on Earth. So in the first mile, there should be 8 inches of curvature. Second mile, 32 inches. And by the third mile, there should be 6 feet of curvature. So how do we measure for that curvature, right? So there's this very simple way to measure for that. So again, if we went to a giant lake that was miles across, like a giant lake, and once the water is at rest, if we physically measure the surface of water, it's going to show us that it's going to be a horizontal surface, a level surface. Because water, when contained and at rest, always forms a level surface. That's what water level means.
Yeah.
But they're trying to tell us that water level means curve. In other words, that there's going to be curvature of 6 feet in 3 miles. But if nobody's ever observed or measured a lake like this, the surface of a lake will always be a horizontal plane, a level plane, regardless of distance. So again, a physical measurement of the earth has never been done because it would debunk the curvature of the earth. So this will be the number 2 proof, is that water, when containing at rest, always forms a level surface like this. So that's why the oceans are considered, have you heard of the term sea level? Sea level? Like
Sea level.
sea level. Have you heard of sea level? Like how we measure height and depths from sea level? Yeah. Again, the oceans, sea level just means horizontal oceans, pretty much. That's another way of saying it. That's what sea level means. So this will be the number 2 proof to debunk the globe. Again, water, the physics of water. So besides images, because obviously images, you know, could be fake nowadays, especially videos too. Besides images and video, is there anything else that convinces you or makes you believe that the earth is a ball?
I think some people like travel start from the specific site and then it can go
Circumnavigation is what you're saying? Circumnavigation?
back.
Yeah. So circumnavigation can happen on a level surface as well. For example, if this was our center point, for example, this tower, and let's say it was the magnetic north, right? If we simply went east, which we would just simply make a circle around the center point.
Oh, okay.
Does that make sense to you?
Yeah.
Because a center point will be north, but if we went east, we'll just do a circle around it, and we'll come back to the same spot. So a circumnavigation will work on a level earth and a globe earth. So that doesn't prove either or.
Yeah.
So,
Makes sense.
so yeah. So is there anything else besides that? Because that's inconclusive to prove for either or. So here's another thing. I know you guys are familiar with GoPro cameras.
Yeah.
GoPro? Yeah, the fisheye lens.
Yeah.
You guys are familiar with the fisheye lens. It warps the image in front of you. So a lot of people that skydive, for example, or go on an airplane, for example, and they use an action camera like a GoPro, you're gonna get an image like this.
Oh,
and people think they're seeing the curvature of the earth, but the reality is just the lens that makes this happen. If you use a standard lens like on your phone, the horizon is always gonna be horizontal. Because in my opinion, that's where the word horizon comes from horizontal. So again, so the only place you're ever going to see curvature of the earth is through GoPro cameras like this or through CGI images like this. Again, curvature of the earth doesn't exist, and nobody has ever measured it or even seen it with the naked eye, you know. Again, a lot of people think they see it, you know, but in reality, if we did see it, then we should be able to physically measure it like this. But we can't, you know. So again, this is, in my opinion, this is the number 1 lie on earth. It's what the earth actually is, you know, as a whole. At the end of the day, I don't know what the earth is as a whole. All I know is that it's a level plane that's pushing up against you, and it's a contained system as well. So we're like inside a terrarium, in other words. That's what the earth is.
So how to explain the sun, like,
Yeah.
right?
So the sun and the moon, nobody have ever been to these places. I know the moon landing was a thing in the 70s, but all of that was just done in a studio. But nobody knows what they actually are. And in my opinion, when it comes to the shape of the earth, what the ground is doing, looking up at the stars, is a red herring. In other words, it's a false argument. So if we want to prove whether the earth is curving or not, looking at the sun or looking at the moon tells us nothing about the ground. So again, it's an irrelevant point. Nobody knows what they are. That's the reality. You know, in my opinion, the sun and the moon are just part of this creation. Because the earth, in my opinion, is a creation. I don't know what the creator is. I know there's a lot of religions out there that try to tell you what that is. The reality is nobody knows. But the fact is that it is created somehow. Because even the first law of thermodynamics says that, and we can, obviously everyone can understand this, nothing, something cannot come from nothing. So we're experiencing something. It didn't come from nothing. But the heliocentric model tries to tell us that the Big Bang came from nothing. That defies physics. So again, this points to the direction that this place is a creation, you know, of some sort. But nobody knows what that actually is. You know, only religions are going to try to tell you what it is. But they're just, in my opinion, religions are just there to try to control people. You know, try to stump people mentally, you know. And believe it or not, the heliocentric model, the ball Earth belief, and that's the biggest religion on Earth because majority of people believe that. But it's just based on faith. It's not based on physics or any real science, in other words. Again, real science shows that the ball Earth is physically impossible. Again, water and the fact that the force of the Earth is a... Do you guys have any questions for me about this subject? You guys heard of this subject before, right?
No.
Have you guys heard of flat Earth?
Yeah, long time ago.
Long time
There
ago.
are two arguments. Like some people think it's flat, some people
The
think
fact is, both the globe Earth and flat Earth are both wrong.
it's
So the debate that's going on online.
Uh-huh.
So here's the thing: the Earth is a level plane. The difference
Level
between
plane?
the
What
difference
does that mean?
yes, the difference between level and flat is that over 95% of flat earthers claim the Earth is motionless. So they deny the fact that the Earth exerts a force. So motionless flat Earth and globe Earth are no different because they both believe that objects accelerate down in free fall. But the reality is, when you release an object into free fall, it's the Earth that comes up to meet it. So that's what's happening. It looks like this goes down because we're also moving up with the Earth. So it's the Earth that comes up to meet a falling object. So objects don't fall down. It's the Earth that catches up. So again, all flat earthers, all mainstream flat earthers believe the Earth or claim the Earth is motionless, which is bullshit too. It's not true. So people like myself that expose both of those models are completely censored online, like super censored. I've been in this subject for almost 10 years now. I came across this when I was 24. I'm 33 now. And I'm telling you, this is by far the biggest subject and the most censored subject right now. The fact that gravity is not a pull, is a push. Because even flat earthers are claiming that too as well. They're defending the globe Earth without even knowing. So they're just falling into another concept that defies physics. You know? So again, the Earth's force is a push. Pulling forces actually don't exist. Everything that has motion requires a push. A combustion engine, boats, everything, airplanes, helicopters, everything that moves requires something else to push it to move. That's the only way. Forces are only push, not pull. I know in our classes they teach us that force is a pull or a push, but the pull aspect of a force, it doesn't exist. It's all push. It's all pressure. You know, the reason that air has air pressure is because it's being pushed, not because it's being pulled. You know, that's the reality. Yeah. So you guys have any questions before you guys go about this subject?
Yeah, it's interesting.
No, very
Yeah,
interesting.
it's
Trust me, like my world got turned. People would say upside down, but in this sense, it got turned right side up. Because now everything makes sense to me. You know, a lot of I would, as a child, I would question my reality a lot. Like, what is this place? What are we as humans, right? And that whole mentality was just stumped because I believed that in evolution and the stories that they told us, the fact is nobody knows what we actually are. That's the reality. And I think that's a much healthier place to be than just believing something, because then that's just a religion, you know. And I like to stay scientific. I like to stay, objective. Whatever reality shows me, that's what I go with. I don't have beliefs, because that's for religions, and I'm not religious. So yeah, that's just the way I see it, So here, you guys can take my information. This is my channel, and I go to other universities as well. And inside are the 6 top proofs that debunk the globe Earth, on top of the fact that the Earth's force is a push, not a pull. So you guys can check that out when you're free time. And yeah, I do these kinds of conversations all the time at different universities. All right, appreciate the chat, man.
Yeah, thank you.
Yeah,
Nice
take
to
care.
meet you.
Yeah, nice to meet you guys. Thanks for the chat. All right. Yeah, no problem. Take care.